Imagine walking through a windswept valley in Ice Age Europe. The air bites at your skin. Every breath feels painfully cold, and silence hangs over the frozen landscape until a massive shape emerges from the mist. At first glance, you think it's another human. Then it steps closer. Its chest is astonishingly broad. Its shoulders seem almost impossibly thick, and every movement carries the confidence of an animal that has spent its entire life overcoming danger. This isn't the stooped, dim-witted caveman you've seen in old illustrations. Standing before you is something far more unsettling. A human built like a professional powerlifter, capable of surviving in a world that would overwhelm most people today. For generations, Neanderthals have been misunderstood. Popular culture painted them as crude, slow-thinking brutes who were destined to disappear the moment our own species arrived. Yet, each new fossil, each archaeological discovery, and even fragments of ancient DNA have steadily dismantled that image. The closer scientists look, the more remarkable these ancient humans become. They hunted some of the largest animals that ever walked Eurasia, endured injuries that would be life-ending for most modern people, and survived in one of the harshest environments our genus has ever inhabited. They were not failed humans. They were specialists, shaped by evolution into something uniquely suited for an unforgiving world. That raises an extraordinary question. How did Neanderthals evolve into perhaps the most physically formidable humans ever to exist? The answer begins long before the first spear was thrown or the first mammoth was hunted. Hundreds of thousands of years ago, much of Eurasia was locked in a relentless cycle of advancing glaciers, bitter winters, and rapidly changing landscapes. Forests expanded and vanished. Open grasslands stretched for miles, supporting enormous herds of mammoths, woolly rhinoceroses, wild horses, giant deer, and other Ice Age giants. Every hunt carried enormous risks, and every failed attempt meant precious energy lost in a climate where calories were as valuable as shelter. In a world where survival depended on confronting colossal prey at close range and enduring relentless cold year after year, evolution favored bodies unlike anything seen in modern humans. Bone by bone, muscle by muscle, generation after generation, Neanderthals became living proof that nature could reshape humanity into something astonishingly powerful. For Neanderthals, survival was never simply a matter of finding food. Every day demanded a contest against an environment that seemed determined to eliminate anything too weak, too slow, or too fragile to endure it. During much of their existence, Eurasia was gripped by the Ice Age, a landscape where temperatures regularly plunged below freezing, glaciers advanced across entire regions, and the seasons could shift dramatically over the course of a lifetime. Vast grasslands stretched beneath gray skies, interrupted only by scattered forests and rocky valleys. It was a beautiful world in its own way, but also one of the most dangerous places any human species has ever called home. The animals that dominated these frozen plains were unlike most creatures alive today. Herds of woolly mammoths wandered across the tundra, each weighing as much as a modern African elephant while protected by thick layers of muscle, fat, and shaggy fur. Woolly rhinoceroses grazed nearby, carrying massive horns capable of killing with a single charge. Cave bears claimed caves that humans also sought for shelter, while wolves and enormous cats constantly competed for the same prey. Every successful hunt meant confronting animals that could easily crush bones, gore hunters, or trample an entire hunting party in seconds. For a body built like our own, this world would have been brutally unforgiving. Modern humans excel through endurance, planning, and cooperation, but a lean physique offers little protection when a 2-ton rhinoceros suddenly changes direction or an enraged mammoth refuses to fall after the first spear strike. Neanderthals faced these encounters repeatedly over hundreds of thousands of years. Failure often meant serious injury or death, leaving evolution with little room for compromise. Natural selection responded by gradually reshaping nearly every part of the Neanderthal body. Generation after generation, individuals with broader chests retained heat more effectively in freezing climates. Stockier limbs reduced heat loss while providing greater leverage for close-range combat with enormous prey. Denser bones better absorbed tremendous impacts, and larger muscle attachments allowed extraordinary strength to develop throughout the body. These were not isolated traits appearing by chance. Together, they formed an integrated survival system, each adaptation reinforcing the next until Neanderthals became uniquely equipped for a life that demanded relentless physical resilience. By the time their lineage reached its peak, they were no longer simply humans surviving the Ice Age. They had become products of it, molded by countless generations of brutal environmental pressure into a form unlike any other member of the human family, a body built less for comfort than for confrontation. That relentless environment didn't just favor stronger humans. It rewarded individuals whose entire bodies functioned like living tools, capable of absorbing punishment while delivering tremendous force. Over thousands of generations, the Neanderthal skeleton became increasingly compact and robust until it looked noticeably different from our own. Nearly every major bone was thicker, heavier, and built to withstand stresses that would push a modern human body to its limits. Their rib cages flared outward into broad, barrel-shaped chests. Their shoulders were exceptionally wide, their arms heavily reinforced, and even their thigh bones and kneecaps reveal attachment sites for muscles far larger than those of the average Homo sapiens. At first glance, their relatively modest height makes this easy to underestimate. Most adult Neanderthals stood somewhat shorter than modern people, yet they often outweighed us by a considerable margin. That extra weight wasn't body fat. It was dense bone wrapped in powerful muscle. Imagine two people of nearly the same height, except one carries an additional 40 pounds almost entirely as functional muscle and reinforced skeletal structure. The difference would be immediately obvious, not simply in appearance but in every movement they made. The sheer size of those muscles has fascinated researchers for decades. Fossilized bones preserve the scars where muscles once attached. And in Neanderthals, those attachment points are consistently larger than ours, suggesting exceptional muscular development throughout the shoulders, back, arms, and legs. Their bodies were engineered for explosive power rather than efficiency. Every pull, every push, and every thrust could generate enormous force, an advantage that would become invaluable when your prey outweighed you by several tons. Some scientists have proposed that biology itself amplified this strength beyond what bone structure alone could explain. One hypothesis suggests that Neanderthals naturally maintained higher levels of hormones associated with muscle growth and physical development. While this remains an area of ongoing research rather than settled fact, it offers one possible explanation for why their bodies appear so consistently powerful across fossil specimens. If true, they may have developed substantial muscle mass with far less effort than a modern human would require, giving them extraordinary physical capabilities as a normal part of everyday life rather than the result of specialized training. Just how strong were they? We can never know with absolute certainty, but biomechanical reconstructions paint an astonishing picture. Some researchers estimate that an average Neanderthal male could have possessed upper body strength comparable to today's elite strength athletes, while females likely exceeded the strength of most modern men. Carrying heavy loads of meat over dozens of miles, dragging massive carcasses across uneven ground, or wrestling with injured prey may not have been exceptional feats. They were simply demands of survival. Yet perhaps the greatest clue to their strength lies not in their muscles themselves, but in the weapons they carried. Unlike later humans who often relied on lightweight throwing spears launched from a distance, Neanderthals appear to have favored heavy thrusting spears designed for close encounters. That meant approaching dangerous animals within just a few meters before driving a spear forward with overwhelming force. Every hunt became a test of timing, coordination, and raw power. Against a charging rhinoceros or an enraged mammoth, there was no safe distance, no second chance, and no room for weakness. Their remarkable anatomy was not an accident of evolution. It was the physical price of confronting the Ice Age's most formidable giants face to face. Strength alone, however, was never enough to guarantee survival. A body capable of delivering tremendous force also had to endure tremendous punishment. Every hunt placed Neanderthals within striking distance of animals that outweighed them many times over, and every confrontation carried the risk of broken bones, crushing impacts, or deep wounds. Evolution answered this challenge not by making them invincible, but by making them astonishingly resilient. Their skeletons reveal that resilience in remarkable detail. Compared with modern humans, Neanderthal bones were exceptionally thick and dense, particularly in areas that absorbed the greatest mechanical stress. Their arms, shoulders, ribs, pelvis, and legs were all reinforced, creating a framework that functioned almost like natural armor. These weren't simply larger bones. They were engineered to withstand repeated heavy loading throughout an entire lifetime. Every spear thrust, every carcass hauled across uneven terrain, and every collision with struggling prey left its mark, yet their bodies were built to keep going. The fossil record confirms just how demanding that life really was. When researchers examined Neanderthal skeletons recovered from sites across Europe and Western Asia, they found that the overwhelming majority bore evidence of severe injuries that had healed long before death. Fractured ribs had knitted back together. Broken arms had realigned. Crushed hands, damaged legs, and battered skulls all showed signs of recovery. These were not isolated accidents, but recurring events, suggesting that serious trauma was an expected part of everyday existence. One skeleton in particular has become legendary among paleoanthropologists. An elderly Neanderthal known from Shanidar Cave had survived an extraordinary series of injuries over the course of his life. He had lost much of one arm, suffered severe damage to the opposite shoulder, experienced major trauma to his face that likely blinded him in one eye, and probably lost much of his hearing as well. Despite these devastating disabilities, he lived for years afterward. His survival speaks not only to the toughness of his body, but also to something equally important: the support of the people around him. Others must have helped him obtain food, offered protection, and cared for him long after he could no longer contribute as a hunter. Many of these injuries also tell a story about the dangers they willingly confronted. Studies of Neanderthal fossils suggest that encounters with large predators were surprisingly common. Bite marks and healed fractures indicate violent clashes with bears, wolves, and massive Ice Age cats. Yet the evidence rarely suggests that Neanderthals were helpless victims. Instead, researchers believe many of these wounds were sustained while the animals defended themselves against human attacks. In other words, Neanderthals weren't simply surviving predator encounters, they were deliberately challenging some of the most dangerous creatures in their environment. Their bodies seem to have been prepared for exactly this kind of brutal existence. Genetic studies have identified variants associated with thicker skin, sturdier hair, and stronger nails, traits that may have provided additional protection against freezing temperatures and constant physical wear. Their large joints added another advantage. Broad shoulders, powerful hips, and heavily built knees allowed a greater range of stable movement under enormous loads, making it easier to grapple with struggling prey, climb uneven terrain, and recover from impacts that might permanently disable a modern human. Taken together, these adaptations reveal a striking reality. Neanderthals were not merely powerful hunters with exceptional strength. They were living fortresses, shaped by hundreds of thousands of years in a world where surviving one battle simply meant being ready for the next. All of that strength came at a cost. Muscles require oxygen. Dense bones require energy to maintain. A body capable of overpowering giant Ice Age animals cannot function on the same biological budget as a lighter, more streamlined human. Deep inside the Neanderthal body was an engine every bit as extraordinary as its powerful frame. One of the clearest signs appears in their rib cages. Unlike the relatively narrow chest seen in modern humans, Neanderthals possessed broad, barrel-shaped torsos that enclosed significantly larger lungs. Reconstructions based on remarkably complete skeletons suggest that the average Neanderthal enjoyed around 20% more lung capacity than we do today. Some individuals may have exceeded that by an even greater margin. One famous specimen from Kebara Cave in present-day Israel is estimated to have possessed lungs capable of holding nearly 9 liters of air, surpassing the capacity of many elite endurance athletes living today. Their noses were equally impressive. Long, broad, and projecting prominently from the face, they were once dismissed as little more than an unusual facial feature. Today, researchers see them very differently. Those enlarged nasal passages allowed tremendous volumes of air to move rapidly into the lungs while giving cold, dry air more time to warm and absorb moisture before reaching delicate tissues. In an environment where winter temperatures routinely dropped well below freezing, every breath had to be conditioned before it reached the body. Their faces, in effect, functioned as highly efficient natural heat exchangers. All of this points toward a metabolism operating at a much higher level than our own. Maintaining large muscles and producing enough body heat to survive Ice Age winters required an enormous and continuous supply of energy. Estimates suggest that an adult Neanderthal may have needed anywhere between 4,500 and nearly 7,000 calories each day, depending on body size, activity, and environmental conditions. That's roughly double what many adults consume today, and on particularly demanding hunting days, the requirement may have climbed even higher. Meeting those demands was no simple task. Missing several successful hunts in a row wasn't merely inconvenient, it could become life-threatening. Every mammoth, horse, bison, or reindeer represented not just food, but fuel for a biological furnace that could never afford to shut down. Their massive bodies generated heat more efficiently than slender ones, while their shorter limbs reduced the amount of warmth escaping into the freezing air. Together, these adaptations followed a pattern still seen in many cold climate animals today: compact bodies that conserve heat while maximizing survival in bitter environments. The result was a human unlike any living today. Every breath drew in vast amounts of icy air. Every meal replenished an enormous reserve of energy. Every heartbeat powered a body built to withstand conditions that pushed human biology to its limits. Yet despite possessing incredible strength, remarkable endurance against cold, and an engine capable of sustaining it all, Neanderthals were not designed to run endlessly across the landscape. Evolution had chosen a very different strategy. At first, that combination of immense strength, massive lungs, and an enormous energy supply might make Neanderthals sound like the ultimate endurance athletes. It's easy to imagine them running tirelessly across frozen plains until exhausted prey finally collapsed, much like some modern hunter-gatherer societies have practiced persistence hunting. But the evidence tells a very different story. Neanderthals were not built to win marathons. They were built to dominate the opening moments of a chase. Their legs provide the first clue. Compared with modern humans, Neanderthals had shorter lower limbs and a stockier overall build. Long legs act like efficient pendulums, allowing runners to cover more ground with each stride while conserving energy over great distances. Shorter legs sacrifice some of that efficiency, but they offer greater stability, faster acceleration, and more powerful movements over short bursts. It's the same trade-off seen today when comparing a world-class marathon runner with an elite sprinter. The anatomy of their feet reinforces this picture. Their toes were broader and somewhat longer than ours, allowing more of the foot to remain in contact with the ground during each stride. That extra contact increased stability while helping generate explosive force when pushing off. Even their Achilles tendons appear to have differed from those of modern endurance runners. Rather than maximizing the storage and release of elastic energy over thousands of repetitive steps, their lower limbs seem optimized for powerful acceleration and sudden bursts of movement. Hidden inside those muscles was perhaps the strongest evidence of all. Human muscles are made from a mixture of slow twitch and fast twitch fibers. Slow twitch fibers are remarkably efficient, allowing us to sustain activity for long periods with minimal fatigue. Fast twitch fibers, by contrast, generate tremendous force but tire much more quickly. Research suggests that Neanderthals possessed a greater proportion of these powerful fast twitch fibers than modern humans, giving them explosive strength that perfectly complemented their compact frames. When all of these traits are viewed together, a clear hunting strategy begins to emerge. Rather than pursuing prey for hours across open landscapes, Neanderthals likely depended on stealth, teamwork, and rapid attacks launched from close range. They would approach within striking distance, then unleash an explosive burst of speed before driving heavy thrusting spears into their target. Success depended on overwhelming force delivered in seconds, not endurance stretched across miles. In many ways, their entire anatomy reflects this strategy. Their powerful shoulders generated devastating spear thrusts. Their dense skeletons absorbed the violent impacts that often followed. Their immense lungs supplied oxygen for explosive effort, while their fast-burning metabolism quickly fueled those intense encounters. Every feature we've explored so far wasn't an isolated adaptation. Together, they formed a single, remarkably specialized machine, one designed not to outlast danger, but to confront it head-on and win. Physical power, however, tells only half the story. If Neanderthals had simply been stronger versions of modern humans, they would still be remarkable. But beneath those heavy skulls was another adaptation that has transformed how scientists think about them. Far from being dim-witted cavemen, Neanderthals possessed brains that ranked among the largest ever found in any member of the human family. On average, the cranial capacity of an adult Neanderthal exceeded that of modern humans by a considerable margin. Some males reached around 1,600 cubic centimeters, noticeably larger than the average Homo sapiens brain today. At first glance, that seems to suggest they should have been more intelligent than we are. Yet brain size alone has never been a reliable measure of intelligence. An elephant's brain is far larger than ours, but that doesn't make elephants better mathematicians or engineers. What matters is how the brain is organized and what it has evolved to accomplish. Neanderthal brains followed a different evolutionary path. Their skulls were longer and more elongated than ours, giving the brain a distinctive shape rather than simply increasing its volume. Researchers believe that a greater proportion of this additional brain tissue was devoted to controlling their larger, more muscular bodies and processing information from exceptionally well-developed senses. In other words, a significant portion of their impressive neural hardware was dedicated to keeping an extraordinarily demanding body operating at peak performance. Their vision appears to have been especially important. Based on the size of their eye sockets, scientists estimate that Neanderthals possessed larger eyes than modern humans. Bigger eyes gather more light, an obvious advantage in the dim forests, overcast skies, and long winter evenings of Ice Age Eurasia. Processing those richer visual signals required more brain tissue, particularly in regions responsible for sight. Combined with their broad noses, which may have supported an enhanced sense of smell, Neanderthals were equipped to interpret a harsh environment with remarkable efficiency. None of this diminished their intellectual abilities. Archaeological evidence paints the picture of a highly capable human species. They carefully crafted sophisticated stone tools suited to different tasks, selected high-quality raw materials, controlled fire, and planned hunts that required cooperation and communication. They processed animal hides, built shelters when necessary, and adapted their technology as climates changed over thousands of years. These behaviors demanded foresight, learning, and the ability to pass knowledge from one generation to the next. Perhaps even more revealing is how they treated one another. Fossils of severely injured individuals who survived for years after crippling accidents suggest that Neanderthal communities cared for members who could no longer hunt effectively. Such long-term support required more than compassion alone. It demanded communication, shared responsibility, and social bonds strong enough to place the group's welfare above immediate survival. The more researchers uncover, the clearer the picture becomes. Neanderthals were not less intelligent than Homo sapiens. They were intelligent in ways shaped by different evolutionary pressures. Their larger brains were not evidence of superior minds, but of specialized minds, adapted to control powerful bodies, process an unforgiving world, and solve the unique challenges of life on the Ice Age frontier. By now, the Neanderthal body almost seems assembled from the strongest parts nature could offer. Yet, perhaps no feature has been misunderstood more than its face. To modern eyes, the long skull, projecting brow, broad nose, and massive jaw can appear intimidating, even primitive. But evolution doesn't design faces to satisfy appearances. Every unusual feature existed because it helped solve a problem. Their skulls were longer and lower than ours, giving them a distinctive profile unlike any living human. Large brow ridges arched above unusually wide eye sockets, while the middle of the face projected forward around the nose and upper jaw. Rather than being random quirks, these traits complemented the powerful respiratory system and enlarged sensory organs that had already become essential for life in the Ice Age. Those oversized eye sockets housed larger eyes than our own, allowing Neanderthals to gather more light during the long, dim winters of Eurasia. Better low-light vision would have been invaluable when tracking prey at dawn, navigating dense forests, or remaining alert to predators during fading daylight. Their broad noses likely enhanced this sensory package even further, helping them process scents carried across cold, open landscapes, while simultaneously warming the freezing air rushing into their lungs. Their mouths also reveal an unexpected story. For decades, scientists assumed that such enormous jaws and thick teeth must have produced a crushing bite force capable of snapping bones with ease. Surprisingly, biomechanical studies suggest otherwise. While Neanderthals certainly possessed a powerful bite, it was probably not dramatically stronger than that of the upper range of modern humans. Their oversized teeth seem to have served another purpose. Evidence from microscopic wear patterns suggests they frequently gripped objects with their front teeth, effectively using their mouths as an additional hand. Whether holding hides while scraping them, gripping wooden shafts during toolmaking, or stabilizing materials for cutting, their teeth became part of their toolkit. Over a lifetime, those repeated tasks left distinctive patterns unlike those typically seen in modern human populations. That behavior also matched their diet. Isotopic analyses of Neanderthal bones indicate that they obtained most of their calories from meat, placing them among the most carnivorous humans known. Large herbivores supplied the fuel needed to maintain their enormous bodies, and processing carcasses would have required constant use of both their tools and, quite possibly, their teeth. Seen together, the Neanderthal face takes on an entirely different meaning. It wasn't the face of a primitive human struggling to survive. It was the face of a specialist, shaped by countless generations to breathe frigid air, detect prey in fading light, manipulate tools with remarkable efficiency, and thrive as one of the Ice Age's most formidable hunters. Around 40,000 years ago, the Neanderthals vanished from the fossil record. Exactly why remains one of paleoanthropology's greatest mysteries. Climate change repeatedly transformed the landscapes they depended on. Modern humans expanded across Eurasia, competing for territory and resources. Small, isolated populations may have struggled to recover from disease, environmental instability, or simple bad luck. More likely than not, it was a combination of many pressures rather than a single catastrophic event that brought their remarkable journey to an end. Yet they never disappeared completely. As modern humans encountered Neanderthals, the two species occasionally interbred, leaving behind a genetic legacy that still survives today. Millions of people carry small fragments of Neanderthal DNA, quiet reminders that our evolutionary story was never a straight line but a tangled family tree whose branches sometimes crossed. Perhaps that is the greatest lesson Neanderthals leave behind. They were never the clumsy cavemen of popular imagination, nor were they failed versions of ourselves. They were a different solution to the same challenge of being human. Evolution shaped them into immensely powerful hunters with resilient bodies, sharp senses, complex minds, and societies capable of cooperation and care. Every unusual feature, from their broad chests to their massive noses and powerful hands, was an answer to the unforgiving world they inhabited. When we look at a Neanderthal skeleton today, we aren't looking at an evolutionary dead end. We're looking at one of nature's boldest experiments in what a human could become. And in a small but meaningful way, that experiment is still alive, carried quietly within the DNA of millions of people across the world, reminding us that humanity has always been far more diverse, resilient, and extraordinary than we once imagined.